Hi everyone, my name is Shrinja Atalori, and this video is part of my Intro to Psychology class at UCR. Today we'll discuss action and membrane potentials and how neurons send electrical signals throughout the body. So let's get started. What is a membrane potential? Before these neurons even send signals, they have a built-in electrical charge called the membrane potential. This is the voltage difference between both the inside and the outside of the neuron. At rest, this would usually be around negative 70 millivolts, meaning the inside is slightly more negative than the outside. The sodium-potassium pump. The neuron tends to maintain this resting charge using the sodium-potassium pump, a specialized protein in the membrane. It moves 3 sodium ions out and 2 potassium ions in, keeping the inside of the neurons more negative. This pump is always working in the background to ensure that the neuron resets after it fires. What is an action potential? An action potential is an electrical signal which is sent by a neuron to communicate with other cells. It occurs when the neurons get excited and reach a certain threshold, usually around negative 55 millivolts. If the neuron reaches this threshold, it fires and sends an impulse. Phases of an action potential. An action potential happens in 3 main phases: depolarization, repolarization, and hyperpolarization. Depolarization is when the neuron reaches negative 55 millivolts and the sodium channels open and sodium rushes in. This makes the inside more positive, reaching around positive 30 millivolts. Repolarization is when the neuron wants to return back to normal, so the potassium channels open and the potassium rushes out, returning the charge back down to negative. Hyperpolarization and return to resting state. After repolarization, the neuron sometimes overshoots and becomes even more negative than negative 70 millivolts. This is called hyperpolarization. But don't worry, the sodium-potassium pump kicks in again, which restores the resting potential so that the neuron can fire back up again. So, why is this all so important, and why does it matter? Action potentials allow for the neurons to send messages. Without these action potentials, your muscles would be unable to move, and this would make it impossible for you to be able to feel or even think. To wrap up, neurons use membrane potentials to stay ready and action potentials to send messages. This process is important for everything, including moving your hand and even listening to this video. So, thank you for watching.